Dividing 3-digit by 2-digit numbers. Learning goal. I can divide 3-digit numbers by 2-digit numbers using area models and using other strategies. A computer screen has an area of 693 square centimeters and is 21 centimeters high. How wide is it, and how do you know? I used a centimeter grid and drew a line 21 centimeters high. Then I tried to fit in base 10 blocks worth 693. I could see that a 20 centimeter by 30 centimeter section would hold the 600 part. Then I put rods next to the hundreds to match the height of 21. There are still 63 square centimeters left to include. Since 63 is equal to 21 plus 21 plus 21, there would be 3 more columns in my grid. I can see the width I end up with is 33 centimeters. So I started off with a grid of 21 by 30, because I knew that was going to get me close. Then once I did that, I could put in the remaining 63 on the end here. So there's 30 up the top, 30 below, and 3 more at the bottom. Choose one of these numbers, 400, 612, or 725, and imagine having that many different stickers. If you make an ebook with 12 stickers on a page, how many pages would you need for your stickers? Let's start with 612. If I've got 612 different types of stickers, and I can put 12 stickers on a page, that means I'm taking that 612 stickers and dividing it by 12, because that's how many will fit on each page. Before solving this using a method for division, let's look at it intuitively how we might solve it using what we already understand about multiplication. Supposing I wanted to see how many 12s go into 612. Well, if I could start off, I could make a guess. I could say, well, what if I had 50 times 12? 5 times 12 is 60, so 50 times 12 must be 600. I'm getting pretty close. That means I've just got one more to go. 51 times 12 should give me 612. If I have 612 stickers, and I divide them by 12 stickers per page, I'm going to end up with 51 pages of stickers. Suppose someone had rolls of stickers to share. Decide how many stickers each person would get if they each get an equal share. Show your thinking. So 18 people share 157 stickers. My first thought would be, well, what if I give each person 10? Well, that would take 10 times 18 people would mean 180. But that's too many. I've only got 157. So what about 8 times 18? 8 eighths are 64. 6 to carry, that's 144. Now I'm a little too small. How about 9? 9 times 18, 162. So I'm too much. So I can give each of those 18 people 8 stickers, which will use up 144 of the 157 that I started with. That means that I'll have 157 minus 144 left over. Now, supposing I had 585 stickers, and they're being shared with 27 people. So the first thing that I think of is that if I've got 27 and I multiply it by 20, that's going to give me 540. But that's still a little ways below 585, but I'm getting pretty close. So if I start at 540 and add in another one, so another 27 people, I'm now at 567, and if I add in another 27, I'm at 594. So here I've gone too far, so I know that I can do 20 plus one more, so I can do 21 stickers for each person, which means I've used up 567 of the 585. So 585 minus the 567 is a difference of 18. So that means there's 18 left over. Make up a problem with an answer of about 15 that involves a 3-digit number being divided by a 2-digit number. So our answer has to be 15. So my problem might be, there are 75 cookies, and they're put into 5 bags. How many cookies in each bag? And the answer, of course, is 15. Why can you use division to solve the problems in both Action Question 1 and Action Question 2? A possible response is that in one question, I needed to figure out how many equal groups I could make, that is, the number of pages that would hold 12 stickers each. In the other question, I had to figure out the size of the equal groups, that is, how many stickers each person might get. How does breaking up the 3-digit numbers into hundreds, tens, and ones, or into tens and ones, help you divide? An example response is that when I divided 585 by 27, it helped to think of how many tens are in 585, so that I'd know how many tens are in a share. How does thinking about division as the opposite of multiplication help you get an answer or check an answer? Well, it means that whenever you have a question, such as 35 divided by 5 equals 7, you can always go back and do the multiplication to make sure that you get the same answer. So therefore we can say 7 times 5 should equal 35. So anytime you've got a division question, you can go back and do the multiplication to solve. Why might a remainder have different meanings in different problems? Sometimes a fraction of a unit makes sense, but sometimes it doesn't. Like a fraction of a page makes sense, but a fraction of a sticker doesn't make sense. When you're measuring ingredients in a recipe, you can add half a cup of milk. But when you go to a corner store and you have enough money for 1.5 chocolate bars, you can only buy 1 chocolate bar because you can't buy half a chocolate bar. A rectangle model can show both multiplication and division. This rectangle has an area of 13 by 12, or 156 square units. So the rectangle above shows 13 by 12 equals 156, but it can also show that 156 divided by 12 is 13. You can figure out the quotient in a division problem by arranging base 10 blocks to form a rectangle. For example, to divide 238 by 14, start with 2 hundreds blocks, 3 tens blocks, and 8 ones. Using the blocks, try to form a rectangle that is 14 units wide. You may have to do some regrouping first. Here you can see the solution. So we start off here. We can see that we've got a 100 block, and then we've got another block here, which is 40. Then down here we've got 1, 2, 3, 4, 5, 6, 7 rows of 10, which gives us another 70. And then here we have 4 rows of 7, which is 28. And just like we've done before, we can confirm that when we add it all together, we get 238. Well, we can also see that if we take that 238 and divide it into 14 columns all the way across, that there are 17 rows going all the way down. So 238 divided by 14 will give us 17. You could show this symbolically like this. 238 divided by 14 equals 140 plus 98 divided by 14. The 148 represents the 2 main sections of the array. So if we go back to the previous page, you've got the 140 up here, and then the 98 down here. The 14 represents one of the dimensions of the rectangle. There are other ways to show it symbolically as well. Sometimes a division equation involves a remainder. For example, once you know that 238 divided by 14 equals 17, then it must be true that 245 divided by 14 is equal to 17 with a remainder of 7. So how do we come to that conclusion? Focus on these 2 numbers to start with. 245 is bigger than 238, and it's bigger by exactly 7. So if you take 238 and add 7 to it, you get 245. So once we know this piece of information, we know that that divides, and our remainder here is still less than what we've been dividing by, we know that we're going to end up with that as a remainder. What you do with the remainder depends on the problem. If the problem is about sharing 245 stickers among 14 students, then each student will get 17 stickers and there will be 7 stickers that aren't allocated to other students. If the problem is about evacuating 245 flood victims in minibuses that each have 14 passenger seats, then you'll need 18 minibuses so that nobody is left behind. So in this circumstance, we'd end up with a minibus, at least one of the minibuses, that isn't actually full. If the problem is about cutting 14 equal pieces from a ribbon that's 245 centimeters long, then the pieces each need to be 17 7/14 long. Remember that when we see something like 7/14, you can divide both the top and the bottom by 7, and you get 1/2. So this should have been written as 17 1/2. Key terms from this lesson: quotient is the result of dividing. For example, in 20 divided by 5 equals 4, 4 is the quotient. Remainder is the number left over when you divide. For example, 36 divided by 5 equals 7 with one remainder. Now it's your turn.